So we continued working today on using a drawing to solve a problem. So you had this story that there are 6 grade students who are standing in a circle for a PE game, and they were evenly spaced and numbered in order. And the really important hint is that the 7th student is directly opposite the 17th student. And you had to use a drawing to try to figure out how many students are in the circle. So once you understood the problem and we decided we'd use a drawing, I suggested you draw a circle and put the 7th and the 17th on opposite sides of the circle. And since they're numbered, you could fill in the right side of the circle and then count how many numbers there were. And then on the left side of the circle, since you have to begin counting at 1, you just back up 7, 6, 5, 4, 3, 2, 1. And now you have 6 people on the left side of the circle, so you need 3 more, so we filled in the 18th, 19th, and 20th person. Alright, so today we worked on open sentences in mathematics, and remember there were 3 ways from the beginning of the chapter we were going to use variables, and one of them was to describe patterns, and another one was in formulas. So today's the 3rd way to use them to represent an unknown quantity. So we started by having Philip stand up, and if we increased his height by 10 centimeters, it was equal, whoops, typo there, it was equal to 157 centimeters. Let me fix that. So we can think about this as representing Philip's height with an h. So that's our unknown quantity. We don't know how tall Philip is, but we can write an open sentence to represent this situation mathematically, also known as an equation. So when you have an open sentence, we have a situation where h could be any number, but not all of those numbers will make this sentence true. So it can be true or false. So we started off by saying if h was 140, would it be true or false? Well, 140 and 10 is not 157. It's only 150, so if we put 140 in for h, it's a false sentence. So what you want to try to figure out in math is what would h have to be in order for it to be true. And we worked on just using logical reasoning and mental math, or guessing and checking. So just using logical reasoning, you all knew that, if I want to know what number I add 10 to get 157, I want to go 10 less than 157, and you all knew it was 147 centimeters. Okay, then we tried using guessing and checking from several choices, and this situation was 3 times the number plus 15 is equal to 45. So we started off by guessing and checking 5, and you said that 3 times 5 and 15 is too small. It equals only 30, so that didn't work. Then you tried 10. 3 times 10 is 30, and 30 and 15 is 45, and voila, that works perfectly. And then I asked you if 10 works, is there any way 20 could work? And you all agreed no, 20 is going to make it too big. There's only one correct answer, and that answer has to be 10. Okay, then I just had you do this mentally. So what do I have to take away from 30 to get 28? You all knew it was 2. So we're not using any kind of formulas today. We're just using mental math or guessing and checking. Alright, and then we also worked on inequalities today. So this is a sentence that uses any of these symbols. So you have to know the symbols in order to communicate effectively in mathematics. So this is a greater than symbol, and this is the greater than or equal to symbol. This means less than, and this means less than or equal to. And this is a not equal symbol, and you need to be able to use this symbol. For example, if I said 5 divided some number x is equal to something, I need to know that my x can never equal 0. Because remember, we can never divide by 0. That's undefined in mathematics. So here are the same things, but just with some numbers. So we could say 5 is greater than negative 2. 29 is greater than or equal to 29. It happens to be equal to it. 30 is greater than or equal to 29. It happens to be greater than it. So that's what that greater than or equal to means. 12 is not equal to negative 12. They're opposites. 7 is less than 18. And 785 is less than or equal to 790. And this balance scale is to show you that we're talking about two things that are not in balance. They are not equal. So then some of you wanted to know, well, when would you ever use this stuff? Well, use this stuff for real situations. So to be able to drive a car alone in Austria without an adult with you, you must be at least 18 years old. So we can write an inequality to represent this, and it's a very efficient way to represent any age of a person. So if we let A be the age of the person, we could say A is greater than or equal to 18. This means that you can be 18 or 19 or 20 or 21 or 22. If you say that you're at least 18 years old, that means you could be 18 or older. So that's when this kind of an inequality comes in very handy to be able to communicate effectively. Okay, then you had to figure out what is the length of this architect's drawing for this department store if the width of the store has to be 40 feet, and we know that the store is 5,000 square feet. So we can again use our formula, area equals length times width, substitute what we know, the area is 5,000, the width is 40, and we're looking for L. And I said use mental math, and let's just use guessing and checking. So we're given the choice of 80, and most of you know that since 8 times 4 is 32, 80 times 40 will not equal 5,000. Then we tried 120, and 4 times 12 is 48, so again that will not equal 5,000, but it's close, 4,800. And then we just looked at 1,000 because really quickly you can tell 4 times 1 is 4, so there's no way 40 times 1,000 is going to equal 5,000. It's way too big. And then we figured the only one that makes sense is 125 feet, because this was just a little bit too small. And then I had you all check it with your calculator, and yes, 125 times 40 is indeed 5,000 square feet. Okay, then we had a different kind of a problem. We're going to use a formula to find the percentage of wins that a team has had. So we can use this formula, the wins divided by the sum of the wins and the losses is greater than or equal to our percentage, because the story is the team has a percentage of at least 0.625 wins. That's a percentage, literally, is 62.5% wins, but if we leave it as a decimal, it's easier to do the calculation. So the situation is if they lost 12 games, at least how many wins did they have? So we use some guessing and checking to see which one makes sense. So if we substitute 6 for the wins, we end up with 6 divided by 6 plus 12, and that's 1/3, and 1/3 is not greater than or equal to 0.625. Then we tried 15, so 15 over 15 plus 12 is 15 divided by 27, and again that was 0.5 something, and it was not greater than or equal to 0.625. And then we tried 20, and 20 divided by 32 is exactly 0.625. So 20 is the least number of wins that makes this true. Now if we try 25, that gave us even a better percentage, 0.675 something, but the question was literally at least how many wins? What's the smallest amount of wins that they could have and still have this formula be true? And that would be 20 wins. And then we played heads together, heads apart, and you mentally had to figure out what x was, so no calculators. And for this first one, x is 12, and for this one, x is 3, and x is 45, because 45 divided by 9 is 5, and x has to be 20 because 100 divided by 20 is 5. And if this is a square, which I told you it was, and you know the area, then the length of the side of the square is the square root of 121, which is 11 units by 11 units. And then again, what number times 5 gives you 40, and x was 8 units. And then I gave you some orally, and you worked together in your groups with heads together, heads apart. And just in summary, you can write an open sentence and find the solution using mental math, logical reasoning, or by guessing and checking. And an inequality means that they are not equal. So take your choice for homework. You can either do the basic or do the challenge, but make sure you show all of your work from pages 112 to 114. And that's it.